back to the channel. Thanks for coming. Today I have something a little bit different. I want to share a simple framework I came up with to break down and think about AI industry as it is. It's a simple first draft of the framework. I want to share it with you, get feedback from the community. Plan to use it later in videos to discuss the AI industry, how it evolves, potentially use it to answer questions about where AI is heading. So thanks for checking it out, and without further delay, let's get into it. So the framework has 5 major components. Those are data sourcing, model design, training, inference, and venue. Each of those components encapsulate functional tasks or capabilities that make up the assembly line, if you will, of building, training, deploying AI to actually be useful for humans. Let's go through these in order. So the first component is training, data sourcing, and cleaning. And this is really about sourcing human-generated data across a wide spectrum of topics, putting it into a format that can be used for AI model training. AI model training is heavily dependent on the training data, and it requires a lot of it. So if you think about companies that play in this space, these are companies that have a lot of human-generated content. So Reddit, Wikipedia, Stack Exchange, pretty much any social media company, your Meta, Google, and including legacy media. So the back catalog of the New York Times, for example, has a lot of value. It's all written by humans for a purpose, but all that content and data is useful for training AI models. So the next is model design. Model design is defining and building the characteristics of models so that they are in alignment with the model goals. So depending on what the model builder is trying to accomplish. So defining the number of parameters, the context window, attention mechanisms, token size, all those things, all those levers that can be pulled to change how an AI model performs. Basically, it's similar to software development. It's a little bit different, but it has a lot of overlapping concepts. There's a lot of investment and innovation here. Companies that you see, I think the most prominent is probably OpenAI with ChatGPT kind of capturing a lot of mind share, if you will. Google, their Gemini model came out a couple months ago, had some birthing issues, if you will, but that's a big one. And Meta's going open source with their Llama model. So that is model design. Training. So this is combining the data that we've got in our first step with the model that has been designed in the second step. This includes building and running the infrastructure required. So training AI models is very compute intense, takes a lot of time and a lot of data and a lot of compute horsepower. And it's basically putting the data through the model that has been designed and using tools like backpropagation to tune or train the model. There's weights and biases in these models, and using the data to adjust those so that the model actually creates useful outputs. Companies in this space, NVIDIA, huge. They provide hardware, specifically processors that can run in parallel that can help with speeding up the training of these models. OpenAI is training models, and they're actually partnered with Microsoft. Microsoft supplies compute credits to OpenAI, and I think that's how they have a reciprocal agreement. They get to deploy their models through Copilot is the brand, Microsoft branded name for it. And Google and Meta, they're both training models. So inference, once the model is designed, built and trained, it's trying to put it to use. This is actually the execution of trained models in order to provide AI-generated responses to prompts. So this is executing the model that's been built, designed, built, and trained. So kind of a fairly different number of players here. Any of the web service kind of cloud platforms can be used for this. AWS, Azure, Google. There's Deep Infra is a company that really focuses on the inference part of AI. And then NVIDIA last year announced that they were partnering with Google Cloud to provide specific processors for inference. And then lastly is venue. This is where this is the user experience of AI, the UI of AI, if you will. This is where the human encounters the capabilities of AI. I expect this will expand over time, but this is where people actually consume the outputs of AI and make use of them. So today, the great example is Microsoft Copilot. If you're writing a Word document and you've got a button, you can use the Microsoft Copilot AI to help you write the document, edit the document, those types of things. I think any of the companies that currently have good experiences or are dominant user experiences in the technology space can expand here. Apple, obviously huge. Meta, Google, these large companies that have technology that interacts with people every day certainly have a potential to be a big player in this part of the AI industry. This is just a framework. Plan to expand it. Curious for any feedback folks have, but key questions that I think that we're going to try and think about and use this framework to answer. So, what are all the connections between each of these components? There's different players in each one. How do they interact? When will model performance plateau? Which part of these components will be the limiting factor? I don't think we know yet. It may be speculative to think about it now. It's so early, but I think it's an interesting question. Will one company dominate the entire industry? Does any single company have an ability to dominate all parts of the industry? So there's many different players in each part of this, each with strengths and weaknesses in each part. Will anybody become the dominant player? And then which companies have advantages in each part? And then how does money flow through the industry now? And then how will it flow 5 years from now? I think we're so early, we don't really know. How will the industry interact, and how will all this work be paid for? And then which part of the industry will be decisive in picking winners? I think this is a good starting point to help us think about all the interactions between these players, but, trying to think about generically which aspects of each component will be decisive in picking winners. So this is the framework. I'd love to have any comments below, any feedback. Curious if anybody has any other frameworks they'd like to talk about. But thanks for checking it out, and we'll see you next time.